Okay, so I want to look at maybe maybe three more problems from section 4.4. So I'm just going to say section 4.4 continued again. So remember we were using some of our rules in order to be able to rewrite logarithms. So somebody who took good notes, like what was the number that the example number we ended with last time? Was it 15 or what was it?
I don't have the number, but it was the problem was log base 6 minus 2.
Did anybody number them?
The number that you stopped numbering over, like you expanded on one of the problems.
Okay, well, we'll just start the numbering over again. All right, so I want to look at kind of one of each using the three rules so that you can see kind of what that looks like. So if you're asked to solve something like this, the first thing you need to notice is I can't really do a rewrite step right now because I have two logarithm terms. So I'm going to pay attention to the fact that I have a plus sign, and I'm going to use one of my three rules, right? And if it's addition, we're going to use which rule? Product rule. So product rule says that you're allowed to combine things to a single logarithm as long as you multiply. So then we would distributive property this. So we would get the log base 2 of x squared minus 3x equals 2. So I almost always, on test 3 in particular, have students just completely forget that this is a log base 2 problem and just like drop it and be like, okay, I'm going to set x squared minus 3x equal to 2 or something. You're not allowed to do that, and you do need to remember that we always want to do the full rewrite step. So the rewrite step, and we'll do it over here, says that 2, so base to the answer power has to be x squared minus 3x. So notice now this becomes something I can move over, right? 2 squared is 4. So I get 0 equals x squared minus 3x minus 4. And then you can either factor or use quadratic formula, but we get x minus 4 times x plus 1 if you factor. And so we end up with two answers, but remember with these we always want to verify if they're valid or not. So what kind of things can we not take logs of? Can't take logs of negatives. We also can't take logs of 0, just FYI. But notice if we try to plug this back in to check, we're going to be taking the log of a negative, so this is invalid. Remember, you actually need to physically plug it back in before you decide if it's valid or not. And so in this case, we only get one answer. Okay, now, we've been doing a lot of problems last time and this time where we get two answers, one of them gets kicked out. But just so you know, both answers can be legit. Like if both answers are fine when you plug them back in, keep them both. And actually both answers can get kicked out too. What if both answers were invalid? What would you say about the whole thing then? It has what? No solution at all, right? So even though the common thing is for one to get invalidated and one to stay around, that is definitely not always the rule. So let's look at the same exact problem, but notice, what did I change? So it's the same exact thing everywhere except for what? I changed the plus sign to a what? To a minus sign. So I actually need to use which rule instead of product? Quotient. So this is going to give me the log base 2 of x divided by x minus 3 equals 2. So don't do anything goofy like try to cancel out the x's. You're not allowed to do that when you're adding and subtracting in a fraction. But you do need to remember the same thing that I just told you back in the example we just did. You've got to remember this step. Okay. So the rewrite step looks like base to this power equals whatever we started with. So essentially I get 4 equals x over x minus 3. So last class we did one like this, but if I put this over 1, then I need to use what process to simplify this? I'm going to cross multiply, right? If I have a fraction equal to another fraction, I can cross multiply. So this times this equals that times that. So I end up getting 4 times parentheses x minus 3 equals 1 times x. So just keep your details straight. Make sure you distributive property everything. So you get 4x minus 12 equals x. And so I'm going to move the 4x this way, even though it's going to give me a negative, just so that I have something on either side. So that's going to give me negative 12 equals negative 3x. And then last but not least, divide by negative 3. So what does it look like x is then? Negative 12 divided by negative 3 is 4, right? So then we would check to see, does this answer make sense or is it valid? And notice we don't get negatives or anything squirrely like that, so that's a completely legit answer. Okay. So I hope you kind of see the process here, right? We're combining using the quotient rule, so we have one logarithm, and then we are remembering to rewrite. Those are probably the two most commonly forgotten things when we're trying to solve logarithmic equations like this. So please, please, please try to remember those. We didn't do one like this last class, so I want to show you, occasionally you might be using the third rule. We tend to use product and quotient rule a lot here, but remember we also have a third rule that's called the power rule. So let's look at one where maybe we would use that. So what if I told you to solve for 2 times the log of x equals the log of 25? So notice this one has logs on both sides, so you're not going to be able to divide by 2. I mean, you could, but then you're just going to get something ugly over here, and I don't really think that helps you, okay? So what we're going to do instead is we're going to notice that, hey, this 2 right here could move where? To the exponent spot right there, right? So I'm going to use power rule in order to rewrite this another way, because power rule says that you're allowed to move the exponent to the front, or if it's already in the front, you're also allowed to move it back to the exponent spot. Okay, so note that the bases are the same, right? The bases are both understood to be 10. So I'm going to set x squared then equal to 25 and just proceed from there. So if the logs are already the same, I kind of don't need to worry about them. It's not that I get rid of them, it's that I'm not concerned about them. And then if you want to get x, you would take the what of both sides? How do you get rid of x squared? You square root it, right? Don't forget, you're technically supposed to say plus or minus. So you actually get 2 answers. But which one wouldn't make sense for our purposes? The negative one, right? So I'm going to say x equals 5 and x equals negative 5, but we're going to say, nope, can't be this one. Because if you tried to plug this one back in, you'd be taking the log of negative 5, and we can't do that. Okay, so the single answer that works, that doesn't get kicked out, is positive 5. So we have 3 logarithm rules. Remember, those 3 logarithm rules match the 3 exponent rules, right? So if you know product, quotient, and power rule for exponents, we're really just making a jump to have the same version of the rules for logarithms, right? Power, quotient, and product rule. So.
Name distinction?